What if you could fast forward your life, not just days, but eons into the future? Black holes offer a bizarre, albeit one-way ticket. We're diving into how these cosmic behemoths warp time so severely that a moment near them could reveal the distant future, including perhaps the end of the universe itself. Imagine this: you could witness the final moments of our universe, not through the lens of a sci-fi blockbuster, but by traveling for just a few seconds. This isn't make-believe. It's a direct consequence of one of the most profound theories in physics, Einstein's general relativity. Near a black hole, the fabric of spacetime itself gets stretched to its absolute limit. This intense gravity creates a phenomenon called time dilation, where time slows down dramatically for anyone brave enough to get close. Let's be clear, this isn't just a tiny, imperceptible slowing. The closer you get to the event horizon, the point of no return, the more extreme this effect becomes. A few seconds for you could mean millions or even billions of years passing for everyone else back on Earth. You'd essentially become a time traveler, hurtling into the distant future. This idea of having a distant future self isn't just a cool concept. It's a real prediction of physics. Your personal clock would tick at a crawl while the universe's clock races forward. So what would this cosmic journey actually look like? Let's explore this with a classic thought experiment, the twin paradox, but with a cosmic twist. Imagine two twins, Alex and Ben. Ben stays safely on Earth, while Alex pilots a sophisticated spacecraft on a daring mission to orbit a supermassive black hole. Alex doesn't cross the event horizon, but gets incredibly close, executing a perfect slingshot maneuver around it before heading back home. For Alex, the entire trip might feel like just a few years. He experiences the routine of space travel, watches a few movies, and maybe celebrates a birthday or two. But for Ben, back on Earth, an entirely different story unfolds. As Alex orbits the black hole, time for him slows to a mere fraction of what it is on Earth. Minutes for Alex could be centuries for Ben. Ben lives his life, grows old, has children, grandchildren, and great-grandchildren. Generations come and go. Human civilization evolves in ways we can't even fathom. New technologies are born, empires rise and fall, and humanity might even expand to other star systems. By the time Alex's ship returns to Earth, he would be only a few years older. But he wouldn't recognize the world he left behind. Millennia would have passed. The continents might have shifted. The constellations in the night sky would be different. Everyone he ever knew would be long gone, existing only in history records, if those even survived. He would be a stranger in a future he inadvertently created for himself. A second for the traveler becomes an eon for the observer. This isn't just a paradox. It's the mind-bending reality of gravity's power over time. The view from Alex's window wouldn't just be of a swirling accretion disk. It would be a fast-forwarded movie of cosmic history. This extreme time dilation is more than just a theoretical curiosity. It's a one-way ticket to witness the grand finale of the cosmos. As our intrepid traveler Alex orbits the black hole, he's not just aging slowly. He's effectively watching the universe evolve and fast-forward. Looking out his window, he'd see the familiar stars of our galaxy begin to change. Stars are not eternal. He would see them swell into red giants and then fade away into white dwarfs, one by one, like cosmic embers dimming in the night. Entire constellations would blink out of existence. He would see galaxies, which normally take billions of years to interact, dance around each other. The Milky Way and our neighbor, Andromeda, would perform their long-predicted cosmic merger. From his vantage point, this galactic collision would look like a spectacular, accelerated celestial ballet, a swirling vortex of gas, dust, and trillions of stars creating a new, larger galaxy. He would witness the birth and death of stars on a scale that is impossible for us to comprehend. The expansion of the universe itself would become visible. Distant galaxies would appear to recede faster and faster, their light red shifting until they disappear from view entirely, leaving his new home galaxy isolated in an ever-expanding void. He would be watching the universe slowly stretch and cool, heading towards its ultimate fate. It's the most profound cinematic experience imaginable, a front-row seat to the end of everything as we know it. So, what is this ultimate fate he would be witnessing? After the last stars have burned out, the universe enters what scientists call the degenerate era. It's a period of unimaginable darkness and cold, populated only by the remnants of stars, black dwarfs, neutron stars, and black holes. But even this isn't the end. Over timescales that make the current age of the universe seem like a fleeting moment, Even these remnants will decay. The grand theory of proton decay, if correct, suggests that all matter will eventually dissolve into a sea of particles and radiation. The universe will become a thin, cold soup. The only organized structures left will be the black holes themselves. And then comes the truly final chapter. Even black holes are not forever. Stephen Hawking showed that they slowly evaporate through a process now known as Hawking radiation. Our traveler, still orbiting his time-distorting patron, would watch as even the most massive black holes slowly, incredibly slowly, radiate their mass away, shrinking over trillions upon trillions of years until they finally vanish in a final, faint pop of energy. After that, only a vast, empty, and cold void, inching ever closer to absolute zero. A state of maximum entropy known as the heat death of the universe. He would have seen it all, from the vibrant, star-filled cosmos we know to its final, silent, and empty state. A journey of a few moments to witness eternity. What we've been discussing is the ultimate, natural time machine. A black hole isn't a device we can build or control, but a feature of the universe that demonstrates the malleability of time itself. It's a terrifying and awe-inspiring prospect. While harnessing this effect for practical time travel remains firmly in the realm of science fiction, the forces involved would tear any known material and any human apart. It forces us to confront the deep connection between gravity, space, and time. Could future civilizations, far more advanced than our own, ever learn to manipulate space-time on this scale? Could they build structures that create controlled time dilation, allowing them to traverse the eons? These are questions that push the boundaries of theoretical physics. For now, black holes serve as a profound reminder of our place in the cosmic timeline. They show us that time is not the rigid, universal constant we experience in our daily lives, but a fluid, local phenomenon. So let me leave you with this thought. If you had the chance and could guarantee your safety, would you take that one-way trip? Would you sacrifice everything and everyone you know for a glimpse of the ultimate future? To see how the grand cosmic story ends? The allure of such an impossible journey is a testament to our unending curiosity about the universe and our place within it. Thanks so much for joining me on this journey to the edge of time. If you enjoyed this cosmic exploration, make sure to hit that like button, subscribe, and ring the bell so you don't miss our next adventure into the unknown. Let me know your thoughts on black hole time travel in the comments below. See you next time.